Hello again, this is Johnny B. Walker coming to you from the pre-apocalyptic wasteland, and today we are going to talk about set builder notation. So what is set builder notation? Set builder notation. Set builder notation is a way to describe a set without having to, set builder. That doesn't make any sense. Set builder. It's a way to describe a set without having to list every single element within a set. And that's pretty useful because some sets are really, really large. So with that, we will say that set builder notation is a description of a set. Description of a set. And it looks like this. So we have our brackets, we have a variable x, a bar, that means such that, and then we list a condition. So our variable x is or can be any number. Our bar means such that, and then we list a condition. So in order for x to be a number within our set, it will have to fulfill the condition. So x fulfills the condition. So if any number such that x fulfills the condition. Now let's take a look at a set builder notation, and let's describe or see what the numbers within that set are. So the first one that we will look at is x such that x is greater than 2. So we have, this says any number x such that x is greater than 2. Now let's just pick a random number and let's see if it fulfills our conditions. So our first one is x is -1. -1 is smaller than 2, so it will not be in our set. Let's try x equals 0. 0 is less than 2, and it also will not be in our set. Now let's bump it up a little bit. We'll think about x equals 2. That's a 0. 2 is equal to 2, and it is equal to 2, but it is not larger than 2. So again, 2 will not be in our set. Now let's try x equals 2.0001. 2.001, although it is only very slightly larger than 2, is indeed larger than 2. So it'll be in our set. Let's try x equals 2.00002. 2.00002 is also larger than 2, so it'll be in our set. Now we could go on and on and on like this and describe every single number with any number of decimal places that is a number larger than 2, and we will get a very, very large set, and writing that all out wouldn't be fun. So instead of listing all of these out, we just use our set builder notation to say that our set is all numbers that are greater than 2. So that would be our set. Let's look at another one. We will try x such that x is greater than or equal to 0 and less than 2. And x is not a decimal number. So let's pick a random number again. We'll try x is -1, and -1 is less than 0, and it's not between, so it's not between 0 and 2, and it's not in our set. So now let's try x equals 0. 0 is either less than or equal to 0, so it's in our set. Now let's try x equals 0.5. Well, 0.5 is between 0 and 2, but it's a decimal number, so it cannot be in our set. And now that we see, or have seen that any decimal number cannot be in our set, we will stick to our whole numbers. So we have x equals 1. 1 is between 0 and 2, so it'll be in our set. And now let's try x equals 3. 3 is larger than 2, so it cannot be in our set. Now, our set is going to be, it's going to be 0, 1, and 2. So, set builder notation wasn't necessarily needed, but if we were only given 0, 1, and 2, we wouldn't know what the rules are for the set. So, set builder notation gives us the rules that correspond to this set, which makes it pretty helpful. So that's really it for set builder notation. Let me know if you guys would like to see a small worksheet and some more practice problems. And yeah, so have a good day, boys and girls, and I will see you next time.